Hello, we're going to look at factoring today. Okay, factoring polynomials. And so I do have some notes for you. All right, so factoring polynomials, some key things to remember is that you always want to look for the GCF first. Okay, and remember what the GCF is, the greatest common factor. Okay, and so this is a term that all terms have in common. Okay. All right, so we'll deal with that, greatest common factor. So whenever you're factoring, you want to always look to see if they have a greatest common factor other than one, okay, to pull out, okay? Then we'll run into the trinomials, okay? We'll run into two types, the trinomials 1, and I call it trinomials 2. The 1 is when the A, 1 is when A is 1, okay? And so when you have your, the coefficient of the leading term is 1, that's when you're dealing with the trinomials 1. And when it's not a 1, something other than 1, then I'll call that trinomials 2 because we have to deal with the A and the C. Okay, so just note that in this polynomial, this trinomial, that we have parts of it. Okay, and so this C here, well, this sign of C, this is your product. Okay, and so that determines, helps determine your sign when you're factoring. And this is your sum, which also plays a role, the sum. So remember with the full property, okay? You have the, we're dealing with the full, remember F-O-I-L, this is the first terms, okay? Think about your eyes, okay? The first terms here and here, and then you have your outside of your eyes, so outside, okay, the outer, okay? And then you have your inner, think about your eyes, the inner, okay? This is the inner, this is the outer, okay? The inner and the outer make up your sum. And then you have your last terms, okay? Last terms, which gives you your product, okay? And so you have your last. You have your first, okay? This one, your first. All right, you have your inner, and your outer, okay? I call it the little smile and the big smile, okay? So that determines your sum. Now, notice that, and I know this may sound Greek to you if you haven't seen it before, but if you have a positive product, okay, that means that if the trinomial is factorable, they will have the same signs, okay? They will have the same signs. So, but the sign will be determined by the sum. The sum will determine the sign. So, for example, if you have ax squared minus bx plus c, the product is positive, so same signs, but the sum is negative. So you'll have two negative signs, okay? And if everything is positive, you'll have two positive signs. Now, if your product is negative, that means your signs will be different. But you'll have to determine who gets the positive and who gets the negative. So we'll look at that also. Then you have another method of grouping, factoring by grouping. And this is normally when you have an even number of terms, okay? We won't go past four terms. So if you have 2, of course, that's one group. If you have 4, possibly we can make 2 groups, okay? So the whole object is to get the same factor to pull out, and it's called a binomial GCF in our case. Then you have special patterns that you may run into, the difference of squares, a squared minus b squared. The factors are a plus b and a minus b. You just have to recognize your perfect squares, okay? And the difference is not a plus. It's the difference. Because plus makes, you won't have those two factors, okay? Because you'll need a middle term. And then your difference of cubes has a formula, a cubed minus b cubed, factors into a minus b, times the quantity of a squared plus ab plus b squared. And then the same with the sum of cubes, a cubed plus b cubed. The factors are a plus b, and then times the quantity of a squared minus a times b plus b squared. But again, it's a matter of recognizing that is the difference of squares, or that is the difference of cubes, or that is the sum of cubes. Or I'm factoring a trinomial that can be factored into two binomials. So it's going to take practice. So let's look at some problems. All right, and so let's look at some factoring problems. And this gives you some practice. Okay, so you can do more practice under the study plan, which gives you thousands of problems to do to practice. So let's look at even like the G. It starts off with the greatest common factor. Okay, and so again, it's a matter of knowing, okay, how to find the greatest common factor. What number or what variable do they have in common? And so if we look at this, and again, you can use the question help, and it should give you some guidance, view an example, and it does well. So let's look at the example, because that does a great job of breaking it down. Okay, and so if we look at 30x to the fourth, 130x to the sixth, and 60x to the ninth, well, you can probably you might be able to look at it and see what is the greatest number that will divide into 30, 130, and 60. Okay, and so right away, when you're dealing with the greatest common factor, it's not going to be lower than the lowest number. Okay, 30. Okay, and so your thing is, you start off with right with 30 going to all of them. Okay, you could go that route. However, okay, what they did was break it down to the prime factorization. So remember, and let me just show you, let's go back. We'll look at 30, okay? And we break it down to the prime factorization. We're trying to find out what two numbers multiply to give you 30. So you can start off with 3 times 10 if you want to. And prime number means the factors are 1 in itself. So if it's prime, you circle it. So 3 is prime because the only factors are 1 and 3, okay? But 10 is not prime, so we got to break that down. And that's broken down to 2 and 5. 2 is prime, circle it, that's an apple. Circle the 5, that's prime. So this is why they have 2, 5, and 3. And I normally put it in order. So I would write it as 2, 3, 5. And then we have 4 x's. Okay. Same thing with the 130. They break it down to 10 times 13. Then they break down the 10. So I would have 2, 5, and 13. And then for the 60, you can do 6 times 10. 6 breaks down to 2 times 3. 10 breaks down to 2 times 5. And these are all prime right here in the circle. So I have 2 times 2 times 3 times 5. So they wrote it out as 2 squared. Okay. So, and then you have 9 x's. So they didn't write out 9 x's. But when you're looking at what they have in common, okay, and I would have written this out 2 times 2. Okay. So we can see exactly what they have in common. So what they have in common, they have 1, 2 in common, all 3. And see, they have a 5 in common. Okay, that's as far as the number. So they have a 2 and a 5, 2 and a 5. Okay, and then what do they have? How many x's do they have in common? So it would be, they have 4 x's in common. So that's the x to the 4. So you just found the GCF. That's 10x to the 4th. Good. And so they start you off by getting you comfortable with finding the greatest common factor, okay, because that's the first thing you want to look for when you're factoring. So if you do have a GCF, okay, when you are factoring, we're able to pull that out. And so we'll see that next. All right, so 10x to the fourth. So let's go back. And if you hit continue, they will go through the same process as we did, okay, to get that answer. All right, so that's an example. All right, so let's move on. Okay, so now they're still getting you set up, dealing with the greatest common factor, that kind of thing. So if you have, when you were dealing with division of polynomials, okay, so if we have 45 x to the fourth is equal to 5x squared times some term, okay? Basically what we're doing here, we're looking at it like this: 45x to the fourth divided by 5x squared, because we can bring in our equation solving skills, okay? In order to solve for the unknown, we divide both sides by 5x squared. And so now we have to simplify, okay? Numbers you treat as numbers. 45 over 5 reduces to what? 9. And then you have to apply your laws to your exponents. You can, okay? Or you can write this out 4 times, write that out twice, and then cancel that way. But we're dealing with division, so that's x to the 4 minus 2. So that's 9x squared, okay? So that's the missing 9x squared. And so if you multiply this out, you get 45x to the fourth. So that's what you're doing. All right, so that's just getting you set up, okay? They're taking you step by step, okay? Finding the GCF, all right? Now, suppose you want to split up a term. How do you do that? So that's getting you prepared for factoring by the GCF. Okay, so now we're getting to factoring. Okay, so factoring. So if you're asked to factor, and they help you out a little bit, but let's just write it as it is. Okay, so this is a binomial. First thing we look to see if we can factor is the GCF. Okay, what do they have in common? So we've already established that the GCF is 7. Okay, so we're going to pull 7 out of each one. So when we say pull it out, we're really dividing each one by 7. So if we divide each one by 7, that will let us know what's left in the factor. Okay, so when you divide by 7, you're left with y plus, and 70 over 7 is 10. And so this whole thing is your factors of 7y plus 70. Okay, that's it. And that's factored by the GCF. All right, so that's 1. All right, so now, and you can do more practice, okay? Of course, this practice doesn't give you a whole slew of 50 problems to do, but you can do plenty of practice in the study plan. All right, so now we get into factoring by, this is a trinomial, okay? So here, let's look at that. So that's just one thing for the trinomial. We can do some more. If you have questions on the greatest common factor, it's the same. So we have this one. This is a trinomials 1. Okay, so trinomials 1. Okay, again, you always look for the greatest common factor, and we can see that they have nothing in common other than 1. Okay, and so if this is factorable, it's going to factor to 2 binomials. And so here we know the x squared. How do we split up x squared? Right, x and x, because that gives me x squared. Now the last 2 terms will come from the 42. Okay, product combination. So if I'm looking at the product combinations of 42, we want to look at that. That's going to give me a middle term of negative 13. Now notice here, the product is positive. So that means the signs will be the same. Okay. And in this case, the sum is negative. So the same signs will be both negative. Okay. That's from the rule that I gave you before. So looking at the combinations of 42, and I always start off with like, unless you can just see it, the sign's going to be the same. You probably can see it. So I always start off 1 times 42, and then I go down the list. 2 will go in that 21 times, and then we have what, 3 goes in there, what, 14 times, okay? And then I go down the list, okay? So right now we haven't found anyone so far that will give me 13, correct? I see 4 will not go into it, 5 will not go into it, but 6 will go into it, right? 7 times. Okay, but it's 7, so 8, 9, 10. Okay, so normally, and sometimes you can go past 10. Okay, but another way of kind of seeing if you have everybody, all your factors, even if you do the prime factorization, 6 times 7, and that's 2 times 3 from these numbers here. Okay, you can do 2 and 21, which we have. 1 and 42, we have 3. Okay, so we have 3 and 14, so 3 and this 14. 6 and 7. Okay, so that's pretty much it. Okay, and then 3. Yeah, we did 3. Okay, so that just gives you an idea. Capturing all of your products. And so when you have a long list of combinations, so you have to look through each one. So which one will give you a negative 13? Which one will give you a negative 13? Okay, good. So we get it from here, right? 6 and 7. All right, so now, does it matter which one I put first? No. Okay, and so here. So x minus 6 and x minus 7. Do we see that? Yep, right here. So it doesn't matter which one you put first. Okay, good. And you can actually see this, all right? So we see x times x is x squared. Okay, we can see positive 6 times, negative 6 times negative 7 gives you the positive 42. What you can see is a negative 13x. This is coming from the inner loop and the outer loop. I call it the big smile, the little smile, and big smile. So the inner is negative 6x and the outer is negative 7x. When you add those sum, you get the negative 13x. So that's a check for you. Pull it out because you may not get it on the first go. That's why it's called trial and error. All right, so that's factoring a trinomial into 2 binomials. All right, so this is just, list all the pairs of integers with the product negative 30. So that's like your factor that will give you a sum of negative 29, okay? And so again, this is a product is negative. So if you have a negative product, that means the signs will be different. So to get a negative 29, okay, then, okay. So they're asking you, all right, to list all the pairs of integers with a product that will give you a negative 30. All right, and so you would do all of that, the ones that would give you a negative 30. And then they're going to want you to find the pair whose sum is negative 29. So all those different combinations that they give you that you write down, and then which one would give you a negative 29. So that means that the higher number would have to have the negative. If I'm dealing with 1 and 30, okay, one of them has to be negative. To get a negative 29, the 30 would have to be negative, okay, and the 1 would have to be positive. That's what they're just doing, getting you to see all the different combinations. All right, complete the factoring. This is, then you can do that one. All right, let's look at this one. Let's see, let's look at this one. All right, so if we look at this one, and they give you part of the answer, but let's not look at that one. All right, so x squared minus 3x minus 18. Okay, and we have, again, a trinomial. You always look for the GCF first. Okay, in this case, we don't have a GCF other than 1. And so if it's factorable, it's going to factor into 2 binomials. So I'll do my 2 parentheses. Again, I'm going to repeat the same thing. The product here is negative. So negative product means different signs. Okay. And so we can go ahead and split the x squared, x and x. I know my signs will be different, so I may want to put the signs in last. I know somebody's going to be positive, somebody's going to be negative. So let's look at the combinations of 18, okay? And I know in the last problem, they deal with the signs, okay? I just deal with the number, okay? 18, I just do the combinations, okay? So 1 and 18, 2 and 9, 3 and 6, okay? And it's good when we don't have a long list, okay? So can I get a difference of 3? From 1 to 18? No. What about 2 and 9? No. What about 3 and 6? Yes. Okay. How would that combination give me a negative 3? So I would have to have a positive 3 and a negative 6, correct? Okay. Because that would give me a negative 3. So that means a plus 3 and a minus 6. And they've already given you the first one. So that means you're on the right track. So this whole thing, these are your factors of x squared minus 3x minus 18. Okay. Good. And the reason why, the reason why you're factoring is because when you solve these quadratic equations, factoring is one of the methods that you may be able to use when solving nonlinear equations, specifically quadratic. Okay, same thing. All right, so now, all right, let's get into the trinomials too. Okay, I'm going to show you a different method. You can do trial and error. Okay, I'll show you 2 ways. I'll show you 2 ways. Okay, and you can pick the way that you like, whichever is easier for you. And you might have another totally different method. Okay, that works. But let's do it 2 different ways here. So here, this is a trinomials 2. Because we have a number other than 1 as my leading term, okay? And see, the GCF of all 3 is just 1. They have nothing in common other than 1. So if it's going to be factored, it's going to factor into 2 binomials. So what we'll do is we'll do the trial and error, okay? Trial and error. That means you try one. If it doesn't work, you got to try something else. And so notice in here that the product is positive. So the signs will be the same. Everything's positive. So we know that everything's going to be positive. So we're going to be adding. Now we have to deal with the 5 as well as the 7 to get the middle term of 36. And so combinations of 5, we have 1 and 5. Thank goodness there's only one combination. Combinations of 7, we have 1 and 7. Thank goodness there's only one combination of 7. So sometimes you may just want to use a trial and error. Okay, it may be quicker. And then sometimes you might want to use the next technique that I will show you. All right, so if we look at the 5x squared, we want to split that up. We'll say 5x and x. That gives me 5x squared. Now, we know we're going to have everything's going to be positive. Now, we only have one combination of the 7. So it's a matter, where do I put the 1 and where do I put the 7? Well, let's see, okay? Let's suppose you put the 7 here and put the 1 here, okay? Let's see if we can get a middle term of 36x. And so it comes from the inner and the outer. So with the inner, that gives me 7x, right? And the outer gives me 5x. Does that give me 36? No, that's not equal to 36x. So what do you think I need to do? Swap the 7 and the 1, okay? So let's swap, erase that, erase that, erase that. And let's see. Let's put the 7 here and the 1 here. So that will give me a 1x, that will give me a 35x, and that will give me a 36x. Good. So that was just a little bit of trial and error, so that works. So your factors for 5x squared plus 36x plus 7 are 5x plus 1 and x plus 7, okay? Or x plus 7 and 5x plus 1. But it doesn't matter the order, as long as you have the partners, the right people together. All right, hold on. Okay. All right, so here. Okay, good. 5x plus 1 and x plus 7. Good. I think you got it. All right, now, let's show you the other way. So now the next way, call it the, what do I want to say? Divide and slide. Because that's what we're doing, divide and slide technique. And this is known, you can find this on the internet. It may be called something else, but pretty much you're dividing and sliding. So the first thing that we do, okay, your steps is to multiply a times c. In our case, we have 5 times 7, which is 35. Okay, then we want to rewrite as the trinomials 1. All right, so that means, all right, it will be x squared plus 36x plus 35. Because it's easier to factor. It seems like it's easier for you to factor when you have a trinomials 1. Okay, so now we can factor this. So factor. And so everything's positive. We have to find the combination of 35. That's going to give me 36. And so we have x and x, right? Combinations of 35. Again, we have 1 and 35, right? And then we have 5 and 7. It's good when we don't have a long list. And so I can get 36 from the 1 and 35. So that's plus 1 plus 35. Now, this is the thing you have to remember to do. You have to remember to bring back A. Okay, divide. And simplify. And so when I do that, let's see. All right, so I'm going to bring back A, and A is 5. So divide each one by 5. That's too light. All right, so that's divide each one by 5. Okay. All right. No. All right, divide each one by 5. And let's simplify. Can I simplify 1 over 5? No. Okay. Can I simplify 35 over 5? Yes. All right, so we have right now x plus 1 over 5 times x plus 7, correct? If it's simplified and you still have a fraction, so fractions left, okay, the bottom slides to the front, okay, slides to the front. So in essence, we have the 5 slides to the left. So we have 5x plus 1 and then x plus 7. That's it. That's your factor, okay? So we divide it and we slid, okay, if necessary. So that technique will work each time. Now, the thing is, sometimes A times C may be a bigger number to deal with, okay? And so you may want to, factor by trial and error, or you may want to use the divide and slide technique, okay? So either one works. Good. All right, so that's the dealing with trinomials 2. Same thing here. Same thing there. Now, now again, every trinomial is not factorable, okay? So some of them may not be factored. You may go through the process, and then you learn that, there's nothing I can do, okay? It's prime. So if it's prime, then it's prime. And let me see if they give you an example. Oh, they're doing the, okay, let me see what they're doing. Let me just trying to see what combinations they're doing, the split. Okay, so what they're doing here is they're doing the factoring by grouping. And that's fine too. They show you how to create, to create a 4 terms out of 3. Okay, to factor by grouping. So that's the method that they use. So that's another method that you use also. So you can look at their technique on how to create 4 terms from 3 terms, okay, to see if you can factor by grouping. And I wanted to do that one so we can see how to factor by grouping works. So let me take part of that. So if we look at, let's suppose we look at this problem right here. We have 10y squared minus 4y minus 15y plus 6. And I just want to show you how the factoring by grouping. Suppose we have 4 terms, okay? And so with the 4 terms, we want to create 2 groups. We'll have group 1 plus group 2. And the whole purpose, you're grouping them because when you factor, whatever's left inside the parentheses, they should be identical. Okay, if they're not, then the factor by grouping will not work. So looking at this one, we'll put the first two together, the 10y squared minus 4y, and then we'll group the negative 15y plus 6. Now we can see we're a little off. This was plus minus, this is minus plus, but that's okay. We can pull out negatives. That will change the signs. All right, so let's look at the first one. So again, it's like we're pulling out the GCF. What do they have in common? What they have in common, they have a 2 and a y. So we're going to pull out 2y. And so in essence, you're dividing each one by 2y. So what's left? So we have, that's 5, and that's y, and that's minus, and that's 2. So 5y minus 2 is left. So that's what I want to be left from over here, 5y minus 2. So in order for that to happen, okay, what do they have in common? So we know they have a 3 in common, but let's pull out a negative 3. Pull out a negative 3. So if we pull out a negative 3, then we're dividing each one by negative 3. And so what's left? Negative divided by negative is positive, so that's 5y. Positive divided by negative is negative, so that's minus 2. So looking at this big picture now, what do they have in common? This is called a binomial GCF because it has two terms. Binomial GCF. So we're going to pull that out. So my factors are 5y minus 2, and I'm left with 2y minus 3. Or if you want to put 2y minus 3 first and then 5y minus 2 second, that's fine. You still get the same thing. I just wanted to show you how factoring by grouping works, okay? Not that you have to use factoring by grouping when you have a trinomial, okay? But you may have 4 terms, okay? You may not be able to combine, your like terms, okay? So that's just, I just wanted to show you that. Good. All right. Okay, so trinomial still. All right, factoring. So this is a process where you are factoring by pulling out the GCF, maybe factoring by grouping, dealing with trinomials 1 and trinomials 2. Now here you get into some special patterns. C squared minus 16. We have 2 terms. Do we have a GCF other than 1? No. Okay. And so do you recognize what 16 is? Yes. It is a perfect square. And so here, recall that when you have the difference of squares, it's a minus b and a plus b. So if I have c squared minus 16, c squared is perfect square. 16 is a perfect square. So that's 4 squared, right? So that's in the form of a squared minus b squared. So what are your factors? C minus 4 and c plus 4. And that's it. That's when you're dealing with the difference of squares. Now you cannot factor c squared plus 16, okay, into 2 binomials. Even if you tried to do, c plus 4 times c plus 4, it will not give you c squared plus 16. Because what happens is you have c squared plus 4c plus another 4c plus 16, right? The 4c's do not cancel out. That just adds up to 8c. So that's c squared plus 8c plus 16. This creates the perfect square trinomial, which is another pattern, okay? Another pattern. So c squared plus 8c plus 16. If you notice that when you're dealing with a trinomial, the first and the last one are perfect squares, it may be that it's a perfect square trinomial, which you get the same factors, okay? And so if we have, meaning if you have like c squared minus 8c plus 16, that the product being positive, same signs, this being negative, okay? So I would have c minus 4 and c minus 4, okay? Because that would give me negative 4c, which gives me negative 8c. Good. So that's still a perfect square trinomial. And sometimes you might see it written like this. Okay? Which means c minus 4 times c minus 4. Very good. All right, so, but I just want, we did the difference of squares, which we can factor. Okay. Same thing here, okay? And this is, even when you have like at the end, the only difference here is you have a y squared. So meaning that it's going to split up into y and y at the end. That's all, okay? That is it. And notice that this is 49, this is 9. They're perfect squares. So when you are factoring, I would probably do the trial and error first. All right, so in other words, let's look at the view an example. This helps us through. All right, so here, and just let you see. All right, and they do that. All right, let's just do the actual problem here. Okay, it's not gonna, when you're doing that, 49x squared minus 42xy plus 9y squared. First thing you look for first is the GCF. They have nothing in common. Not all three have to have it in common. They don't. Okay. And so other than one. And so if it's factorable, it will factor into two binomials. Now notice here we have x squared and y squared. So that's still going to split to x and x. The y squared will split to y and y at the ends. And so I still have to deal with the 49 and I have to deal with the 9 because this is a trinomials too. Combinations of 49, we have 1 and 49, 7 and 7. Combinations of 9, 1 and 9, and 3 and 3. When I have those doubles, that's the first thing I go to. Okay, so let's do 7 and 7 and 3 and 3. Now, the product is positive, so that means same signs. So in this case, I would have two negatives, correct? All right, so let's look. So this inner gives me negative 21xy, and the outer gives me negative 21xy. The sum gives me negative 42xy, which checks out. And so this is called a perfect square trinomial. I like those also. Trinomial. Okay. Okay. Perfect square trinomial. So do plenty of practice. Okay. It's a lot to digest, but if you practice it, you'll become comfortable with it. So when you get into solving nonlinear equations and you have different you know how to factor, if that's going to be one of your techniques, to solve if possible. And again, not all trinomials, not all polynomials are factorable. Okay, so that's why you'll learn about different other techniques on solving nonlinear equations. So have fun practicing. If you have questions, please let me know.